TetraScience connects to many instruments that are used in a typical bioprocess development workflow. This drastically reduces manual data transcription, resulting in a streamlined process. Let's first look at a simple diagram to see how TetraScience collects data from various instruments. TetraScience utilizes different connectors in order to collect instrument data. These include integrations with chromatography systems like ACTA, Empower, and Agilent, as well as IoT connectors for instruments that would otherwise be unable to connect to the internet. In this video, we'll be collecting data from a bioreactor using our Directory Watcher connector, which collects data from a specified directory on a virtual machine. We'll begin by installing a DataHub, which is responsible for collecting data from, in this case, a Windows file share. We'll then create an integration on our DataHub using the Directory Watcher connector. We'll see an example of a new file entering our folder, from which it is automatically uploaded into TetraScience, where it's parsed and standardized. And lastly, from within TetraScience, we'll see how to search for files and tag files with important metadata. As always, our scientific data is available downstream via direct software integrations and a dedicated API. So first, we'll create a DataHub. The DataHub transfers data from our source, in this case a folder on a Windows device, and moves that data onto the TetraScience platform. We'll give our DataHub a name. Once the DataHub is created, we'll download a generated script, which will prepare our computer to run as a DataHub machine. We drag the installation script file into our virtual machine, make it executable, and run the script. Once the installation is finished, we activate our DataHub on TetraScience and can begin adding integrations. As we mentioned before, TetraScience has several connectors that can be run on our DataHub, each developed for a specific instrument and use case, among which the Directory Watcher connector will link to a directory on your computer and upload the files from that directory. In this case, we are connecting to a folder on a Windows machine. To demonstrate, we'll create a new folder and give it a name. Then set the sharing permission on this folder, making it available to our DataHub, and we'll use the folder path to create our integration. Setting up an integration is simple. In this case, we integrate with a GPC bioreactor using a Directory Watcher connector. We'll name our integration, we enter the path information of our shared folder, and we will need to provide a username and password if the sharing is password protected. So now our DataHub and our integration is set up. This means existing files in the folder will be uploaded automatically, and when a new file enters the folder, it will be uploaded automatically to TetraScience where it's processed. We can drop a new file into our folder, and as we can see, our file is now available to us through the search page from within TetraScience. There are a few ways in which we may search for a file. We can simply search for the file name. We can also add custom metadata and search by that metadata. We can add tags to our data files, either manually or automatically. In this case, we'll add a tag to our file manually. This enables filtering on our tags. In this case, we'll use our source filter to return all of our GPC data, and we can continue to filter until we have the file that we're looking for. Keep in mind that our data is now standardized and available to downstream reporting and analytics tools, including IDBS, Spotfire visualization, and as always, via a dedicated API. Upon connecting additional instruments, we are on our way to integrating across our bioprocess development, eliminating manual data transcription and streamlining our process.